Okay, so this is my video on the pre-calc oral assessment for limits, so let's get started. This is the function we have f of x equals x squared minus 5x plus 4 over x squared minus 1. So the first step is to graph the function. So, since this is a rational function, as we can tell from the polynomials on the top and bottom, we know that there's going to be asymptotes. So the first step is obviously to find those asymptotes to graph the function. So the horizontal asymptote we can tell is going to be 1 at y equals 1 because the degrees of the top of the numerator and denominator are the same, which means you divide the coefficient of these two parts by each other. So 1 divided by 1 is 1. So the horizontal asymptote is y equals 0. I mean y equals 1. And now for the vertical asymptote, what we're going to do for this is we're going to factor the function. So first I'll do the top. So we got, let's see, what was this? Yeah, right. Negative 4, negative 1. So we have negative x, negative 4x adds negative 5x. So on the top we're going to have x minus 1 times x minus 4. And on the bottom, let's see here, x squared minus 1, x minus 1, and positive 1. So x minus x add up to make 0. There we go. So at the bottom we're going to have x plus 1 times x minus 1, which multiplied to make that. This multiplies to make that. Alright, so as we can see here, we are actually going to have a hole at x equals 1. So that's something to note. So we'll write a hole at x equals 1 because we have x minus 1 on the top and bottom. So, yep. And we're going to have a vertical asymptote at x equals minus 1 because we have x plus 1 at the bottom, and if x equals minus 1, then that'll make this 0. It'll multiply 0 times this will make the whole denominator 0, and you can't divide by 0, so it's undefined. So there is a vertical asymptote at x equals minus 1. So now we have the basic information we need to graph the function. But we do need one other thing, and what we're going to do for that is right, there we go, my note cards for this here. So since we know that the vertical asymptote is going to be at x equals minus 1, we can tell which parts where the lines are going to be for the graph on like which sides of the asymptotes. So I did this by inserting values that were both above and under minus 1. Okay, sorry, that's my bad. This is actually going to be 3 and 1/3. Yeah, so we'll just write 3.33 repeating for that. So if you insert minus 2 into the equation, to the left of the vertical asymptote, it gives you 3.33 repeating. We can see that's above the horizontal asymptote. So we know there's two asymptotes right now, so the equation will look something like that with its asymptotes. Oh, the asymptotes will look like that, and we know that to the left of the vertical, the graph is going to be somewhere in here. Now, to the right of the vertical, we'll insert x equals 0 to the right of it. So that'll give us 0 squared minus 5 times 0 plus 4 over 0 squared minus 1 is, let's see, 0 minus 0 plus 4 divided by negative 1 because 0 squared minus 1 is negative 1. So we got negative 4 divided by negative 1. So at 0 it's going to be negative 4, which is below the horizontal asymptote. So we know to the right of the vertical asymptote, it's going to be somewhere in there. So based on how asymptotes work, they're going to be approaching, how graphs with asymptotes work, they're going to be approaching the asymptote, but never quite getting there. So it'll look something like that. And as we can see, more specifically, it's going to look like this. As you can see, we have our vertical asymptote at x equals -1, and our horizontal asymptote at x equals 1. And we're actually going to have a hole here at x equals 1. That's a hole. Oh, that's a hole right there. But yeah, that's what our graph is going to look like, so that's part A. Now, next is evaluate the limit as x approaches -1 of the function f of x. Alright, so, as we can see, as x, well, -1 for x is a vertical asymptote. And on both sides of this asymptote, y that is going to be, well, the graph is going to be going in different directions. On the left of it, it's going to be going up as x approaches -1, y will approach positive infinity. And for the right side, as x approaches -1, y will approach negative infinity as opposed to positive. So, because it is going in different directions on both sides of the value of x equals -1, there's going to be no limit because it's not consistent from both sides what it's approaching. So for part B, there's going to be no limit. Okay, so next is determine if the function is continuous at x equals -4. Explain why or why not. Alright, so I have an index card for this. A rule for determining if functions are continuous is that if you insert the value that that the function is approaching, the result of that, the output, will be the same as the limit. So in this case, it will be that if you insert, because it's approaching x equals -4, if you insert -4 into the equation as x, the y value will be the same as the limit. So let's have a look at that here. So as we can see, first I put in some values that were close to -4 but not completely -4 here to determine what it's approaching from both sides, to determine what the limit is. And we'll see here it yields -0.43, and over here it yields -0.51. And so you can see they're both like they're around this -0.4 to -0.5 area. And if you actually insert -4 into the equation, it'll be -0.47. So they're both approaching this value. Like you can tell because they're so close. They're both so close to this value. But so the limit is going to be this. And if you insert the equation, if you insert -4 into the equation, it yields the limit that these show. So that means that the limit as x approaches -4 equals f of -4. So that means it is continuous. To answer part C. So that's my video. Thank you for watching.